must have noticed magnets at one time point of your life, but these magnets play crucial roles in our daily lives. In this video, we will discuss some everyday examples of magnets and magnetic force produced by them. But let's ask first, what is a magnetic force? The magnetic force is a part of an electromagnetic force, one of the four fundamental forces of nature, and it's caused by motion of charges. It can also be defined as an attractive or repulsive form of energy that exists between the pole of a magnet and electrically charged moving particles. These moving charges create magnetic fields, and interacting magnetic fields give rise to magnetic force. Here are some examples of magnetic force in our everyday life. Ever wonder how speaker works? In order to convert an electrical signal into an audible sound, the speaker contains an electromagnet, a metal coil that creates a magnetic field when an electrical current flows through it. It means that it is in turn attracted to or repelled from the permanent magnet, vibrating back and forth. Maglev is a system of train that uses two sets of magnets. One set is to repel and push the train up of the track, and the other one is to move the elevated train ahead, taking advantage of a lack of friction. The next time you travel by train, you'll be amazed to be travel in a huge magnet. A compass is a tool for finding direction. It has a magnetic needle mounted on the pupil or a short pin. The needle can spin freely and always points north. Have you ever been on a hiking or a camping trip? If you did, then some point you must have used compass to help find way. Because compass always points north. But have you ever wondered why it is so? Well, it all caused by the power of magnesium.
Chemistry is everywhere. We rely on chemistry in our bodies, and we do chemistry when we cook or bake, among other things. Solution chemistry is a very common in our everyday life. A textbook definition of a solution is a homogeneous mixture of two or more substances. Dilution is a technique that uses a solvent to increase the volume of a solution and thus decreases the concentration of that solution. It is a concept used in our everyday lives as well. If your coffee is too strong, you add water to it and dilute it and make it more palatable. Many people do this with their juices and other beverages. It can also happen inadvertently when your ice melts and makes your favorite carbonated soft drink or juices taste less sugary. Possibly the most common dilution in our everyday life is the melting of ice in a beverage. The ice is added to the beverage to make it cold. As the ice absorbs the energy, it melts into liquid water, and this dilutes the initial beverage, giving it a watered-down taste. There are products that are available that don't melt at room temperature, but get very cold when kept in the freezer. The addition of these items to a beverage will not result in a diluted beverage.
Feedback is defined as the information gained about a reaction to a product, which will allow the modification of the product. Feedback loops are therefore the process whereby a change to the system results in an alarm which will trigger a certain result. Feedback loops are a part of your everyday life, whether you know it or not. Some examples are thermostats, blood sugar, financial markets. Understanding them can help you see their good and bad sides. It can also help you make better decisions in your day-to-day life.
There are two types of feedback loops. The key difference between positive and negative feedback is their response to change. Positive feedback amplifies change, while negative feedback reduces change. This means that positive feedback will result in more of a product, more apples, more contractions, or more clotting platelets. Negative feedback will result in less of a product, less heat, less pressure, or less salt. Positive feedback moves away from a target point, while negative feedback moves toward a target. Examples of these feedback loops are fruit ripening. The second example of feedback loop is fruit ripening. For example, the ripening of a watermelon. There is a surprising effect in nature where a tree or bush will suddenly ripen all of its fruit or vegetables without any visible signal. This is our first example of a positive biological feedback loop. If we look at a fruit tree with many fruit seemingly overnight, they all go from unripened to ripe to overripe. This will begin the first fruit to ripen. Once ripe, it gives off a gas known as ethylene through its skin. When exposed to this gas, the fruits near to it also ripen. Once ripe, they too produce ethylene, which continues to ripen the rest of the tree in an effect much like a wave. This feedback loop is often used in fruit production, with fruits being exposed to manufactured ethylene gas to make them ripen faster.
Blood clotting. When tissue is torn or injured, a chemical is released. This chemical causes platelets in the blood to activate. Once these platelets have activated, they release a chemical which signals more platelets to activate until the wound is clotted.